In this video, we're going to talk about composition of functions. So in the first example here, I've got a couple of functions. If you're taking notes, obviously pause it and copy this stuff down. But I've got a couple of functions. F of x is 2x plus 7, and I define g of x as 7x minus 1. And what we're going to do is we're going to start out pretty basic, just plug some stuff in. So for f of 1, what that means is we're going to take the f of x function, 2x plus 7, and we're going to put 1 in everywhere we see an x. So this is going to be 2 times 1 plus 7. And 2 times 1 is 2, plus 7 is 9. So this is just evaluating a function. You're just plugging a number in for x. So if we have f of 7, once again, 2 times, instead of x, we replaced x with 7. So 2 times 7, and then plus 7. 2 times 7 is 14. 14 plus 7 is 21. So that would be f of 7. So then g of 1 means we move over to this g function. And so we're going to take and plug 1 in where we see an x. So this is going to be 7 times 1 minus 1. And 7 times 1 is 7, minus 1 is 6. So g of 1 is equal to 6. So for composition of functions, we're going to do something pretty darn similar to this. But take it kind of to the next level. So same f of x and g of x in this example, but this time I'm going to do f of g of x, and this is read, as I mentioned here, f of g of x. So what we're doing in this example is, you notice we're not plugging in a number this time, we're actually plugging in a function. So instead of x into our function, so here's what I typically do. I'll write 2, and then instead of x, I'll just put some big parentheses. And what do we plug in instead of x? Well, we plug in this expression. We plug in 7x minus 1. So we're plugging in the g of x function where there used to be an x in the f function. So we put 7x minus 1 in the parentheses. So once again, all we're doing is we're taking, if you notice, we've got, instead of x, instead of f of x, we have f of this g of x. And so we're plugging in g of x where there used to be an x. So we distribute the 2, just kind of do our algebra steps. 2 times 7x is 14x. 2 times negative 1 is negative 2. So we get 14x minus 2 plus 7. That simplifies down to 14x plus 5, and that is f of g of x. It's 14x plus 5. So then down below, I ask, well, let's do g of f of x. Go the other way. So this time what we're going to do is we're going to start with the g function, and I'm just going to write that down. So whichever one's on the outside, we're going to write that one down. We're going to do 7. Wherever I see an x, I'm going to do a big set of parentheses. And then what I'm plugging in is I'm plugging in f of x, which is 2x plus 7, where there used to be an x in the g function. So g is 7x minus 1. I wrote that down, but instead of x, I put big parentheses, and I'm plugging f in there, so it's 2x plus 7. Distribute the 7 in, we get 14x plus 49, and then this minus 1 on the outside. So this simplifies down to 14x plus 48. So f of g of x and g of f of x in this case are different. They're kind of close. They're 14x's, but the constant term is completely different. So this is, in a nutshell, how composition of functions works. You plug one function in where x, or whatever letter you're dealing with, where x used to be. So here's a couple of examples. And what I would encourage you to do, if you're taking some notes, is pause the video, write this stuff down, and then I'll explain what this whole open circle business means in just a moment. So what this means is this, oftentimes you'll hear calculus teachers call this first example GOF. It looks like it's spelled G-O-F. What this is really saying is it's g of f of x. That's what that open circle means. It means composition. So this open circle tells me we're doing composition. And composition means f of g of x or g of f of x. If it was a closed circle, that would probably imply multiplying. So if it's an open circle, that means we're doing f of g of x or g of f of x. So let's do it. For g of f of x, we're going to start with the g function, which is the square root of x minus 7. And then what am I plugging in for x? Well, I'm plugging in the f function because it says we're doing g of f of x. So under the square root, we're going to do 1/2 x plus 4. If we can simplify it down, we do. And in this case, I end up with the square root of 1/2 x minus 3. And that is simplified down as far as we can take it. So g of f of x ends up being the square root of 1/2 x minus 3. Let's slide over to g of h of x. So I'll rewrite it. G of h of x. So this tells me I'm going to start with my g function just like we did before. That's the square root of x minus 7. But this time I am plugging in h where there used to be an x. It's the h function. So it's x squared minus 9. So then we end up with x squared minus 16. And if we can simplify it down, we do. It is super, super, super tempting to say that this one simplifies down to x minus 4. But it does not. It does not because we would have to factor the x squared minus 16. Whenever you have a plus or a minus happening under a square root, you cannot just take the square root of each of those items. If there's a multiply, let's say this minus 16, whoopsie, that's not what I wanted. Let's back up here a little bit. There we go. Whoopsie. There we go. So if I had, oh man, there we go, finally. Holy smokes. If this minus 16 was a multiply, then we could do that. But, you know, obviously this technology is not cooperating with me at the moment. Okay, so back up a second. This one is simplified as far as we can take it. The square root of x squared minus 16, we cannot go any further than that. All right, let's look at f of g of x. We'll do that one in yellow. No, let's do that in light blue. That one looks good. So this one, the fog, means f of g of x. So this means I'm going to start with my f function, which is 1/2 x plus 4. Oh, but I already messed up, didn't I? Forgot to replace the x. So we're going to do 1/2 x plus 4. And then what I'm going to do is I'm going to plug in g of x in where there used to be an x. So that's going to be the square root of x minus 7. So simplified down is really what we have right now. You could probably get rid of the parentheses. They're not necessary. So we'd have 1/2 and then the square root of x minus 7 plus 4. And that's as far as we can take it. We do not combine like terms because the minus 7 is under the square root and the plus 4 is out of the square root. So we can't combine those to minus 3. It doesn't work like that either. All right, and then this last example we've got here, let's do this one in orange. This is h of g of x, or hog. So it's going to be h of g of x. And so we're going to start with h. We're going to write down the h function, which is x squared. So remember, I'm replacing x with a big set of parentheses, minus 9. And then I'm plugging in the g of x function in. So this would be square root of x minus 7. And if you know anything about square roots and squares, those are reciprocals of one another, or inverses of one another. Those are going to cancel each other out. So this ends up being x minus 7 minus 9. which is x minus 16. So hog, h of g of x, simplifies down to x minus 16. All right, so that is it for composition of functions, the first video. There will be a second video to follow.